This is the same problem 3, but part B. What's the difference now? We have the car, again, same car, which is moving along this semicircular track. And now the coefficient of friction mu is given. Suppose that at time defined as t0, at time t0, the car had velocity of magnitude v maximum over 2. That's the big difference. So that was the velocity of the car just at the time moment t0. The magnitude of the velocity was v max over 2. The car was given a constant angular acceleration alpha naught. So the car was given constant angular acceleration alpha naught. This is constant angular acceleration alpha naught about the center of the curve. What we need to do? We need to obtain a single equation that could be solved for the time. We are looking for the time. I will put it in red. We are looking for the time t capital. Obtain a single equation that could be solved for the time at which the car begins to slip off the road. So it is moving with no slipping, but we need to time when it is ready to slip. Ready to slip. And we need to find this equation in terms of what are we allowed to have in this equation. We are allowed to have r, radius of the curve, given, acceleration of gravity, given, v maximum, given, and alpha naught. All those are given quantities, and we need to express, we need to have only these quantities in our equation for time when it's ready to slip. Let's think about it. So what's happening? The car was given some initial velocity at time moment 0. It is accelerating with constant angular acceleration alpha naught. And yes, at some point, if it's accelerating and accelerating, it will be too much for the car to stay on this curve, and it will be ready to slip. We need to find this time when it is ready to slip. So for magnitude of force of friction that keeps this car on this track is again mu n, where n is the normal force. And we know how to find normal force. It is n minus mg0 projection of net force in z, and we already found it in part A. I will be just using it. Now, what will be the direction of force of friction? Let's look at our formulas. So it's still no slipping. It is right before the slipping occurs, but still no slipping. So r is constant. Radial component of velocity is 0. Tangential component of velocity is non-zero. It is equal to r omega. Do we know omega? No, we don't. We know alpha, and we can find omega at time moment 0 from our tangential velocity. But we need to find omega as a function of time. It changes now. Omega changes as the car accelerates. Okay? So it's still minus m minus m r omega squared. That's still correct. Let's look at f theta. Do we have non-zero f theta component? It is here. I have dr dt, still 0. R is constant. But look at this. Alpha is not 0 anymore. Unlike part A, alpha is non-zero. It is constant alpha naught that is given, a given quantity. I know alpha. Can I find omega if I know alpha? Yes, I can do it. So what is omega? I will write it here. Alpha is d omega dt, it is rate of change omega, which means that omega is integral alpha dt. And alpha is constant, it is alpha naught. I take this integral, it will be alpha naught t plus constant of integration. I need to find this constant. What is this constant? It is omega at time moment 0. What is omega at time moment 0? I need to find it. Omega from this formula is v theta over r, and I will write omega at time moment 0. Omega at time moment 0 is the velocity at time moment 0, which is v maximum over 2, v max over 2. This is v theta divided by r. What is r? It is a given quantity, capital R. So omega at time moment 0 is v max over 2r. Now, I know this constant velocity at time moment 0 is this. I bring it into my formula. What is my final formula for omega? Omega for the car at any time moment. It is alpha naught t plus v maximum divided by 2r. Oh, look at this. We are making progress. Now we know omega. So now we can find f sub r as minus m r omega squared. I will write it here. F sub r is equal to minus m for the car. R is capital R. And omega squared is this expression. It is, omega squared is alpha naught times t. This t is any time moment. I'm just writing fr as a function of time. Alpha naught t plus v maximum over 2r. And this is squared. This is F sub r component of force of friction. Do we have F theta, or our diagram is still correct? Let's check. F theta. Oh, we already checked it. I already scratched out 0. We already know that this is wrong because my force of friction has now two components, Fr and F theta. And F theta is along I theta. I definitely didn't do it right. So let's try to do it better. So my F theta component of force of friction will be along I theta, along the same direction. So both of them are components of force of friction. This is radial component Fr, and this is non-zero F theta. And the magnitude is mu n, so we still need work. We still have work to do. What is F theta? F theta. It is m. R is capital R. And alpha is alpha naught. Now we know both components of force of friction, Fr and F theta. So I need to find magnitude, the magnitude of force of friction. Force of friction, magnitude we find from Pythagorean theorem. It is Fr squared plus F theta squared. And we understand that this magnitude of the force of friction has to be equal to mu n. Ready to sleep, okay? It is mu n. What is n? We already found it from second law in projection in z direction. It is mu mg. Now let's bring everything that we know into our equation. Fr, F theta, and mu that is given. That will be our next line. So, square root Fr squared. Where is my Fr? Here. Minus m r alpha naught T capital, this is this critical T time when it is ready to sleep. Force is equal to mu n. Alpha T capital plus V max over 2R squared. And all this guy is squared. This is FR squared plus F theta squared. What is F theta? MR alpha naught. MR alpha naught squared. Square root. And this is equal to mu mg. Mu mg. Now, look at this. Here is m is not given. We need to figure out what to do with mass. M squared square root. Mass comes out of square root as m, and it cancels out. So mass is not a part of our equation. The last step that we need to do, we need to bring our mu that was given into our equation. So I will write my final equation in red. So what do we have? Square root. I will keep this minus, all the minus squared will be plus. Okay, minus r. And then alpha naught, T capital, plus V maximum over 2R squared. All these guys squared plus R alpha naught squared, square root. And this is equal to mu. What is mu? V maximum squared over GR over G and times G. G will be gone. And all I have on the right hand side of my equation is V maximum squared over R. G canceled out when I brought mu here. So look at this. We did it. We found one equation that could be solved to find time, T capital, when this car is ready to sleep. How did we do that? Alpha was given. We found omega as a function of time. Then we found FR component of friction, radial component of friction. Then we found theta component of friction because we have non-zero angular acceleration. And we found magnitude of force of friction. It is equal to mu n, mu mg. And finally, we got one equation with all known quantities. Problem solved.